Okay. So, today we're going to, oh, sorry. Um, okay, so today we're going to look at this problem, merge intervals, and we developed the solution already. And so now we're going to go over the review and the evaluation portions of this umpire process. So, bear with me, I have to get to this. Um, okay, let's do this, and to the compiler thing. Okay, so in the evaluation portion of this, or not evaluation, but the review process of this solution to merge intervals, we're just gonna pass by these examples. So we have the intervals 4, 5, 1, 4, 5, 8, 1, 5, 9, 10, 10, 14, 1, 5, 8, 10, 13, 15, the interval, and 2, 20, 5, 4, 4, 5, 9, 15, 13, 18, 17, 19. So we're going to test out these cases and see if our code works. And we're also going to just go through one example, the first example in detail. So let's see what we have first. We have the definitions of these two functions first, and then we print our merge function with this and with these intervals. So we have the intervals 4, 5, 1, 4, and 5, 8, and that's inputted into the function. And next we see that the intervals get sorted. So 1, 4 is first, and then 4, 5, and 5, 8. And then we set found equals true. And then while found is true, we set found equals false. Next, then in the interval, we want to start with incrementing I to 0. And then we evaluate the merge two intervals for the interval 0 and index at 0 and 1. And so we have a comparison between these two intervals endpoints, and then we find that our return value is 1, 5, which is the merge of the interval. And so then we evaluate this if value, and we see that it's time to remove the intervals, the two intervals from the intervals collection, and we append the value 1, 5, the merged interval instead. And then we want to sort out these intervals again, and then we see that 1, 5 is first and 5, 8 is next. And then we want to break out of the for loop. Then we go back to well found equals true. So we go into the loop again, and then found equals false. We set found equals false, and then we enter the for loop again. And so we want to compare the first two intervals, which is 1, 5, and 5, 8. And so when we do this comparison of the end value points, the end value of the first interval and start value of the next interval, we find that there is a merge, and we merge the entire interval. And so we return the 1, 8 to the list, and then we remove the two intervals that we had before. that was unmerged, and then we append the merged value, and then we break out of the loop and go back to while it's found. But and then we loop again and see that that the value is false, so we go back to while found and exit and return the intervals. And so that's a big picture analysis of merge. So we also want to see the solution. So the solution is 1/8 in this case for this particular problem, and then we want to see the solutions for the next 4 examples. And so we see for the next merge we have 1, 5, 9, 10, and 10, 14, and we see that 9, 10, and 10, 14 are merged. 9, 14, and 1, 5 is kept alone. And in the second case, we have no merges, and the same for the empty list. And then the last case, we have the entire thing merged. So that's actually the case. So we have a correct solution. So now we want to consider a little bit what the evaluation is in this case. So the evaluation is that we have a solution that has two loops in it. So there's a while loop and a for loop, and so we expect that the time complexity n squared, but for the best case scenario, we would say that first we are considering sorted intervals, so we have to take into consideration what that time complexity is, and that is in log n. And then if we run through this while and for loop, we can take into consideration that that all intervals are merged in this case. If all intervals are merged, then we enter the while loop once to merge the first interval, and then we break out of the loop, and then we go back into the loop to merge the second interval. So it's just actually a single run of the for loop. And so we could say that's an ON time complexity. But if we have, we could say that's ON. And also in the case where we have no merged intervals, this for loop gets just consistently run through, and one time only, and it doesn't jump out into the while loop, so it's also time complexity of O(n). However, if we have n over 2 intervals that are not mergeable, and n over 2 intervals that are mergeable, then we have to run over this for loop twice. I think that leaves us with n squared plus n over 2 over n over 2 times n over 2 times in which we were looping. And so we get a time complexity of n squared. So we have our worst and our best. And so in this case, time complexity. And so we could consider a solution. So there's probably a solution that's only ON, probably a solution that is only ON log n. But so we're not going to consider that for now. It's just this solution, and so we didn't come up with the best solution, but we came up with a working solution. So should pat myself in the back for that. But we also want to consider space complexity, and this is it takes up ON, which is where n is the length of interval. And it just is the storage of intervals into the list. And so I just to wrap up, I think that we could have found a better solution here, but so far, like the best I could do was come up with an n squared O n squared solution. So I think that's good enough. So thanks for listening.